This podcast, we're going to talk about the ideal gas law. The ideal gas is a hypothetical substance. Basically, we need to think of it as a limit, okay? We don't ever actually attain an ideal gas, but we can get really close to ideal behavior if we're at low pressure and high temperature. We're going to use the laws anyways because they give us very good estimates of what's going on. The ideal gas law is defined as PV equals nRT, where P is pressure in atmospheres, V is volume in liters, N as moles, R is the gas constant, and it's equal to 0.08206 always. So we'll always know R. And then temperature is in kelvins. Now, this particular law, the ideal gas law, that tells us how about the gas right now. The other laws we've been dealing with, they give us two different variables. So like pressure 1 and pressure 2, volume 1, volume 2. We're talking about changes in gas laws when we're talking about that. But this particular law, we're talking about it exactly right now with some of these laws in action. All right, first question, how many grams are present in a gas sample that occupies a volume of 138 milliliters? So here's our volume. Now, of course, we've got to get it from milliliters to liters, which means we're going to move our decimal 3 places this way. So it's really 0.138 liters with a pressure of 852 torr. Now we know to get from torr to atmospheres, which is what we have to be in, we need to divide by 760, which gets us a pressure of 1.12 atmospheres. Okay, so this is our P. And then we have 37 degrees Celsius. Now that's our temperature, but we need to add 273. So after we add 273 of that, we get 310 as our temperature. All right, now we need to plug it into our ideal gas equation, which is PV equals nRT. All right, so P we just found out was 1.12. V is 0.138 liters. N, we have no idea. R, that's our gas constant, 0.08206. And T, which is 310. All right, now it's just algebra problem. So we're going to multiply these two. And that gets us 0.15456. And that's equal to N times these two variables multiplied, which gets us 25.4386. Now we want N by itself, so we're going to divide, pretend I didn't cross out the number there. My writing is becoming atrocious. All right, 4386 on both sides. All right, and that leaves us with an N value of 0.00607. All right, now I did make a change to this from when I gave you your copy of the handout. I told you to find grams, but I didn't tell you for what substance. So I had to go back and add a substance because you can't find grams if you don't know what substance. So you need to find it for hydrogen gas. Hydrogen gas is diatomic. So we're really looking for H2, and the molar mass of H2 is 2.0158. We know this is moles, and to get from moles to grams, you need to multiply by the molar mass. So I'm going to multiply this number by 2.0158. Okay, that's the molar mass of H2. So that gives us the final answer, how many grams of 0.0122 grams. Okay? And of course, that needs to be sig fig, so 0.012 Gs. Okay? So that is the final answer. Okay? All right, let's look at a different kind of problem. All right, this question wants us to find the density